All right, guys, this video we're going to cover 1-3 a little bit and sprinkle in a little 1-4. So we're talking about the metric system. And you're probably already familiar with the metric system, or you should be, hopefully. So we're going to go through this kind of quickly. And you probably already know how to do some metric conversions. So like going from kilogram to gram or gram to microgram. Maybe you don't know microgram. Maybe you only know between kilo and milli. We're going to expand that a little bit and go beyond those prefixes. And so you're going to have to be able to convert from micrometer to kilometer, or mega meter to nanometer, something like that. So I want to show you the metric system prefixes that you will be responsible for. You probably know how to do some of the metric conversions, but what we want to start pushing is something called dimensional analysis, and that's covered in 1-4. So 1-3, 1-4 kind of go hand in hand. But the reason, in this class, and on the final exam, if I ask you how many kilometers or in a meter or something like that, or convert this many kilograms to milligrams, you're not going to have to do dimensional analysis for that conversion, because there's different ways to do that. But there's going to be other types of unit conversions that you're going to have to use dimensional analysis. And so we're using the metric system because we already know some stuff about the metric system and showing how dimensional analysis works, so that we can use dimensional analysis with things other than the metric system. Okay, so that's kind of the whole thing. So before you keep going in this video, you should check out some of the handouts that I've already given you. All right, so metric system, things to know. Okay, so the definition of a centimeter cubed is a milliliter. So a milliliter and a centimeter cubed, that's the same exact unit. Don't get confused that a liter would mean a meter cubed. No, it means a decimeter cubed. So decimeter cubed is the same thing as a liter. And then, well, what if you have, I might know how to convert meters to centimeters, but do you know how to convert meters squared to centimeters squared, or maybe meters cubed to centimeters cubed, or something like that? So those units, we got to be careful when all of a sudden we add an extra dimension, right? So meters, instead of meters and centimeters, it's meters cubed, or meters squared and centimeters squared. When we add that extra dimension, how are we supposed to convert that? Okay, so that's what I want to kind of touch upon today. All right, so but anyway, so you want to check out that handout. You want to check out where is it? This handout, the metric system prefixes. Okay, so you're not going to be responsible from tera all the way to femto, but you are going to be more than this range. So you're probably already familiar with maybe this range, kilo to milli, right? So here's our base unit, and you can put any base unit here. You could put grams, you could put seconds, you could put meters, whatever, right? Here's our example. And then you could go to kiloseconds or kilogram or whatever. All right, so you're probably familiar with those. But we're going to expand your responsibility in this course from mega down to nano. Okay, so we're talking about mega, which means 10 to the 6th, and we're talking about nano, which means 10 all the way to the -9. Okay, so we're really never going to refer to hecto or deca, so you're not going to really see those ever in chemistry. But you will see all the other ones between mega and nano. Okay. Now, sometimes we'll talk about picometers when we're talking about lengths of bonds, but we're not going to hold you responsible for that in metric conversions. Okay. So a thing to notice, like on the number line, like notice between kilo and milli, we have a prefix for every single place. So we have it for the for the tens place, for the hundreds place, for the thousands place, the tenths place, the hundredths place, the thousandths place, right? But then once we go beyond that in either direction, it goes up by, it skips 2. So like if you look at the scientific notation, we go to the -1, to the -2, to the -3, and then all of a sudden to the -6, and then to the -9, and then to the -12. So we don't have prefixes for those 2 places. We don't have prefixes for those 2 places. And then once you go beyond kilo, right, we're at 10 to the 3rd, but then we go, our next prefix is 10 to the 6th, and then our next prefix is 10 to the 9th, and so on. Okay, so hopefully, that kind of looks familiar to you. If you're not, if you're more familiar with kind of like the number, the standard notation worth of it, the fractional worth of it, that's fine. But it might be beneficial to think of it in terms of scientific notation. Okay, so like powers of 10. All right, that's a good way to think from now on in your entire hard science career. Okay, so you want to check out that and review that. The other handout is metric system equalities that you are responsible to know. So like you're going to need to know 1 base unit is 10 deciunits, or 1 base unit is 100 centiunits, and so by base unit we mean we could replace base unit here with gram, with liter, with second, with mole, whatever, coulombs. So if I say 1 coulomb is equal to 10 decicoulombs, right? Or 1 mole is equal to 1,000 millimoles, right? It doesn't matter. It's just whatever unit you want. The metric system is just a prefix that is worth a certain amount. Now you can memorize it in terms of these values like here, but notice I didn't write out 1,0,0,0,0,0 or 1,0,0,0 with a lot of units like that. So that's why the scientific notation part is kind of helpful. So you could remember it this way, right? So you need to know those equalities, and because we're going to use those equalities in what we call dimensional analysis, which I'll show you a brief tutorial on in this lesson, but then I'm going to have a more full lesson on dimensional analysis in the next video. Okay, so let's go through it. All right. Whoops, where am I going? I didn't want to open up Excel. All right. So these are the prefixes you're going to be responsible for, right? Mega all the way to nano. Notice that I didn't include deca or hecto, though they're there, but they're not prefixes that you're going to be responsible for. But again, there is no prefix between kilo and mega, but you have to know that we're going from 10 to the 3rd, 1,000, all the way to 10 to the 6th, 1,000,000, right? So you will see deci, you will see centi, you will see milli. We will use micro, and we will use nano, okay? So a way to think of the prefix is that prefix times the base unit. And remember, in math times of means time. So if I see mega, I mean that's 10 to the 6th, or 1,000,000 of the base units. If I see kilo, that's 1,000, or 10 to the 3rd of the base unit. If I see deci, I know that's 0.1, or 1/10, or 10 to the -1 of the base unit. If I see centi, that's 100th, or 10 to the -2 of the base unit. So 10 to the -2 times the base unit, 10 to the -3 times the base unit. So when you get all the way down to nano, nano is this decimal, this fraction of the base unit, or another way to say that, 10 to the -9 of the base unit, okay? All right. So you probably can already do this, right? 15 kilograms equals how many grams, right? You probably did this in 8th grade, or maybe even before then, I don't know. And so a lot of you just know, oh, I just multiply by 1,000, right? And if we were going the other way, like if I had 15 grams and I wanted to know kilograms, I would divide by 1,000, right? A lot of you already know that, and you can do that in your head, and you know the answer is just 15,000. Okay, that's great. All right, but I want us to understand a way to do that same conversion, and it's called dimensional analysis, and actually show what you're doing, right? Because let's understand something. Me saying 15 kilograms or me saying 15,000 grams, I'm saying the same exact thing. This measurement has the same exact value as this measurement. Numerically, it's a different number, right? But 15 kilograms is equal to this many grams. So it's the same thing. All we're doing is unit conversion. And another word for unit is dimension. So we're doing dimension conversion. And a certain way to do dimension conversion, unit conversion, is called dimensional analysis. And I want to show you what you're actually doing when you say 15 kilograms is equal to 15,000 grams, okay? All right. So before we get to the dimensional analysis, you might have, and maybe you didn't know to do that, but maybe you've used this kind of number line system. This is micro, sorry, my handwriting's so bad. But you have your base unit here. You go this way to get bigger, you go this way to get smaller, right? And so what you would do is, if I was doing that same conversion, right, 15 kilograms, how many grams is that? I'm starting at kilograms, so I'm starting at this place, and I want to go all the way to the base unit, grams. So I'm going to go 1, 2, 3 spaces to the right. So if I just take my number 15 and I move the decimal 3 spaces to the right and fill in the zeros, I get the grams, right? If I was going back the other way, grams to kilograms, I'd be going 1, 2, 3 spaces to the left. So I would move this decimal point that's right here, 1, 2, 3 spaces to the left, and that's how I get 15, right? So maybe you've seen this number line and you can remember it. King Henry died, base unit, by drinking chocolate milk. But then you'd have to fill in the rest, because, and now you're not just responsible from kilo to milli, you have to go from mega all the way to nano, all right? So just understand that. But now let's show the dimensional analysis way. And it's the reason why knowing your metric equalities. So again, what I mean by metric equalities are these. This metric prefix equals that many base units. This metric prefix equals that many base units, one base unit. 100 of these centi units equals one metric system base unit, right? Knowing these equalities, all right? So what we're doing is, in dimensional analysis, we're using equalities to convert from one thing to another. Okay, so let's understand how that works. All right, let's say I had 29,000 milligrams and I wanted to know how many kilograms that is. Now, many of you already know you would divide by 1,000 to go from milli to gram, from milligram to gram, and then you would divide by. So again, many of you already know, like, if I wanted to go from milligram to gram, I would divide by 1,000, and then to go from gram to kilogram, I would divide by 1,000 again. So if I take 29,000 and I divide by 1,000, and then I divide by 1,000 again, that will make this conversion. But let's understand what we're doing. Okay, so the equalities I need to know here, these are just two other ways to represent this same equality. So I know 1,000 milligrams equals 1 gram. So that's an equality I need to know for this. And then I also know that 1,000 grams equals 1 kilogram. Okay. Now what we can do with these is make what we call conversion factors. An equality can make two conversion factors. I could say 1,000 milligrams over 1 gram, or I could say 1 gram over 1,000 milligrams. And then here I could say 1,000 grams over 1 kilogram, or I could say 1 kilogram over 1,000 grams. And since those two things are equal to each other, if I make a ratio of these two things, so if I say this over that, or that over this, that ratio is equal to 1, because anything divided by itself is 1, right? And so if they're equal, that ratio is equal to 1, all right? And remember, what happens to a value when you multiply it by 1? You don't change the value. Okay, so what you're going to see is, in dimensional analysis, we're multiplying and dividing by these numbers, but these numbers are coming from equalities, and so we're really multiplying by ratios that are equal to 1. So all we're doing is changing the unit, but not changing the value of the measurement. So let me show you what I mean. So let's take these equalities. So what we're going to do is we start off with 29,000 milligrams, And then I'm going to take this equality and I'm going to put 1,000 milligrams on the bottom because that's going to cancel out milligrams and then leave me with grams. All right. So I put the thing that I want to cancel out on the bottom and I put the thing that I'm trying to go to on the top. But remember, if we go back to the question, this is, we don't want to go to grams, we want to go to kilograms. So if I just did this part of it, I would be stuck at grams, right? But now I'll use this equality. So now I'm at grams and I'll put this part of that equality on the bottom. Why? Because I want to cancel out grams, all right? So when they're on opposite sides of the train tracks here, they cancel out, all right? And now I'll have grams. And so mathematically, we just multiply by the numbers on top, we divide by the numbers on the bottom. And remember, you already told me that you probably knew to just take 29,000 and divide by 1,000 and then divide by 1,000 again to go from milli to kilo. And that's what we're doing here, right? We're dividing by 1,000 and then we're dividing by 1,000 again. And we've canceled out milligram, we've canceled out gram, and the only unit we're left with is, we've canceled out milligram, we've canceled out gram, and the unit we're left with is kilogram. And so we do the math and we get 0.029 and our unit is kilogram. Okay, so this setup right here, this is the dimensional analysis setup. Okay, and this is what we're going to learn about when we get to 1-4. Okay, so review your metric system stuff, right? And then we want to start getting comfortable with dimensional analysis. Okay, now the other thing I'll say is, right, know the definition of a milliliter in terms of centimeters cubed and know the definition of a liter is decimeter cubed. But then let's talk about this, all right? We know you probably, could have given me this metric equality right here, 1,000 meters, 1 kilometer. And it doesn't matter the base unit, right? 1,000 grams, 1 kilogram. 1,000 seconds, 1 kilosecond, right? It doesn't matter what the base unit is. You know kilo to base unit. You know that equality, all right? But here's my question. If I know this equality, what if I wanted meters cubed to kilometers cubed, right? Does that mean if this is the right equality from meter to kilometer, is this the right equality from meter cubed to kilometer cubed? Okay. And the answer is screamingly no. That's not correct. This equality is not right. Okay. This is right. But what happens if I cube the unit? Okay. If you cube the unit, you have to cube the number in the equality. So if you know this, you don't know this, what you're supposed to take from that is this. So if 1,000 meters equals 1 kilometer, then that means 1,000 cubed meters cubed equals 1 cubed kilometers cubed. Now 1 cubed is just 1, but 1,000 cubed is 10 to the 9th. Okay? So understand, knowing this, whatever you do to the unit, do the same thing to the number in the equality. So if I squared it, I would do 1,000 squared and 1 squared. So if I wanted, meter squared to kilometer squared, I would just square these numbers. But if I want cubed, I got to cube those numbers. All right. So that would be the equality right there for meter cubed and kilometers cubed. All right. So we got to be careful about that. And that'll make more sense when we start really working with dimensional analysis. All right. So hopefully that helps with kind of remembering the metric system, and now we just have to get good at dimensional analysis. All right. So that's pretty much 1-3. And then we're going to get into 1-4 dimensional analysis shortly. All right.